Right, welcome everyone to the Flyte Community Sync. Today is March 7. I'm really glad to see you all here. I'm David Espejo. I work as an open source developer advocate at Union AI, and well, happy to be your host today. Again, a friendly reminder that the agenda document is completely open. Feel free to add yourself to attend this list, including your affiliation. It's totally optional. So that's in the logistics side. For today's session, does anyone want to be the note taker? Oh, okay, cool. Yeah, I think we can handle that with the recording. Meanwhile, well, good. Okay, great. Thank you. Next one, please. Right, some community updates by myself. Next one, please. Great. I mean, I love this portion. I mean, contributors of the month, as every other open source project, pretty much is defined and sustained by the contributor community. And from the past month, we had really awesome contributions from Bernard from Pajama. He basically, in collaboration with Flyte maintainers, he wrote the Dask integration, and also he authored a blog post covering all the details. We will make sure to share the links with the recording, also with the newsletter. So thank you, Bernard. I hope you are enjoying your swag. All right, next up, Dr. Fabio Gratz from Recogni. He also wrote a really great blog post covering the way he attached a visual debugger for ML workflows with VS Code and other components, and obviously Flyte. And thank you again for sharing your knowledge. Awesome. Next up, Nick Mueller from Black Shark. He authored what we think is the first RFC, the first proposal that comes from the community around cache overriding and deleting. Thank you so much for caring a lot about the project and submitting a proposal. So thank you for your contributions. And finally, Steph Lindell from Stripe, the author of PR adding support for checkpointing in local mode. Thank you for your contributions. Every form of contribution matters, so we really appreciate you. Thank you. Cool. Okay, next up, and yeah, friendly reminder that I forgot to mention at the beginning, this meeting is being recorded and it will be posted on social media, so probably you don't mind about this, but it's good to remind it. Right, so a couple of things I wanted to share with you all. Probably three, and one that is completely relevant. I always try, sometimes I have to clarify why my handles are mirror. The thing is that mirror is English for my last name, Espejo. Espejo is Spanish for mirror. So I'm also David Mirror. It's completely accurate. So, okay, next up, please. Okay, no. I will share my screen. I forgot about this real quick here. There you go. Yep. Okay, there you are. All right, I'm really happy to share this with you. It's a new governance document for Flyte. So what is governance in open source? It's basically a place where we document the roles, responsibilities, and in general, the way a community communicates and makes decisions. That's basically kind of the design or the architecture in general of an open source community. And with Flyte, we had some design principles in mind to try to come up with this proposed governance model. In general, it's how can we ensure rapid innovation, but at the same time, how to handle chaos, right? Because as a project evolves and grows, chaos becomes bigger and more evident and could hamper innovation. So how can we avoid red taping or adding unnecessary bureaucracy, but at the same time we provide order, structure, and a sense of ownership, a path to higher responsibilities and higher privileges in the community. So the result is this one, as you can see in the community repo under Flyte.org. And here you will find the roles defined here, the responsibilities, ways to contribute, how we envision or define a contributor, a maintainer, and finally the steering committee, who is basically the leadership or the governing body who will make the decisions that will probably change the direction of the project and will ensure the sustainability of the project in the future. So I'm really happy to see, in this case, we are in the process of building the technical steering committee, but I'm really happy and grateful to see Dr. Fabio Gratz and Bernard, who have stepped up to be part of the steering committee, alongside with folks from Union AI and hopefully folks from other organizations, because what we want to have is a leadership or a governing body that is diverse enough to represent the interest of the wide majority of the community, right? So all these could sound as politics, but it's necessary to ensure the scalability. It's one thing to scale up a community, adding more members, etc. But a total different thing is to scale out, to be able to make sure that in the future we will be able to meet the needs and the requests from the community. So feel free to check it out. This is work in progress. Probably the next steps, the couple of immediate steps will be, first, as Neil said, to review the RFC process, because one of the main responsibilities of the steering committee will be to vote on proposals, and the RFC needs to reflect this, make it more transparent, and make it clear for anyone submitting a proposal what to expect and when to expect it. And the other immediate step probably will be to define what we will call special interest groups or working groups, to have more focused work. For example, gather in a single place everyone thinking about integrations, the Flyte ecosystem of integrations, or any other use cases. We will be in the process of, with the consensus of the community, defining this structure. So again, if there's any question, feel free to ask. Yeah, again, thanks anyone who's stepping up to help lead this project. Any question, any comment about governance? Nope. Right. Oh, well, next up, we had a new section in this community sync that we introduced this like a month ago, and we used to call it in-flight conversations because we didn't have a better name. We agreed to call it lightning talks because it's more standard. When we say lightning talk, probably everyone here knows what to expect, something that is short and sweet. It's totally open for anyone out there in the community wanting to share something, even without slides. You probably know something that someone else in the community needs to learn. I'm pretty sure about this. So I'm just kicking off this section, and if you want to get rid of me in upcoming sessions, please propose your own sessions, and this place is totally open for you. So Kubernetes Ingress, yeah, the part of the value proposition of Flyte is that we abstract away many of the complexity or the details of Kubernetes configuration That means that it's a very opinionated platform, but there are some resources that are exposed, and one of them is the Ingress resource. Loved by some, hated by many, but it's necessary. Probably in less than 10 minutes, I will try to introduce why this resource exists, how does it work, and I will expand more details in an upcoming blog post. For some of you, this will be basic, and sorry about that. I'm just trying to set a baseline of knowledge for anyone out there. All right, so imagine that you have a Kubernetes cluster with a single node, single worker node, a single pod. Remember, the pod is the fundamental unit of execution in Kubernetes. And typically there's a single container in a pod, right? Pretty simple. What happens by default is that first Kubernetes will assign an IP address to the pod. That's the first thing. And if you have another node in the cluster and another pod with another container there, Kubernetes will not only assign a different IP address in the same network, but will also enable these pods to communicate with each other, even throughout different nodes. That's the role of the container native interface, container networking interface, or CNI plugin, and etc. But basically, that's what happens. It will assign IP addresses, and it will enable this communication between pods, even throughout different nodes. So if that's something that happens by default, why do we need something else? Well, the reality is that you will most likely will have different applications with multiple pods. And at that point, it becomes impractical to connect to the application using an IP address, because remember that pods are designed to be short-lived. So when a pod dies or is destroyed and it's reinstantiated, redeployed, it will receive a different IP address. So it's not practical to use IP addressing anymore. So enter services. Service is a core Kubernetes resource that basically sits a layer above of IP addresses, and it will provide a central location for anyone out there trying to connect to a specific set of pods. Which pods? Well, basically the pods that will match certain criteria. Here in the right-hand side, we can see the spec of a really simple service that will have a label as selector. So any pod labeled as my app, app.kubernetes.io/name equals my app will be, let's say, captured or covered by this service definition. What does a service do? It's basically a load balancer, or a resource that will receive incoming request through a specific protocol and a specific port, and it will forward those requests to the pods matching the label. In this case, connecting to a specific target port. Right, so the service in this case is exposing the 80 port, HTTP port, and the pods are exposing the 9376 port. So that's it. It's good. It comes by default with Kubernetes. So again, if it works, if it's a load balancer, why do we need anything else? Well, again, probably you won't have a single app in your Kubernetes cluster. You will have multiple apps. So for each app, you will have a different service. And this could create a couple of limitations. First one, as I said, the service provides basic routing functions, basically forwarding incoming requests, and that's it. And if you're running this cluster in the cloud, for every service instance, if you're using the load balancer type of service, probably you will incur additional cost for every load balancer instance. It doesn't come from free. So it can quickly become cost prohibitive while not providing rich networking services for applications. So yeah, we need something better, something that sits a layer above again, not IP addresses, not TCP ports, but at the application layer. And to be able to provide connection points for users or applications. So enter Ingress. So the ingress, in fact, the term ingress comes from networking jargon from several years ago that denotes incoming traffic. There's another term for outgoing traffic, which is egress. So the ingress resource handles incoming traffic purely, right? So it's different from services because it sits a layer above. And how does it look like? Here's a simple definition. And here you can see that we are not capturing requests coming to a specific TCP port, but through host name, right? In this case, bookhotels.com. So anything coming through bookhotels.com/whatever will be redirected to a service. So we don't get rid of services. We still use services as the backend component of the ingress resource, but this is why we need a qualified name. In this case, bookhotels.com is a domain name or a qualified name, because ingress don't operate layers below by using IP addresses or anything like that. It operates at the application layer using host names. Right, so there it could seem like it's very similar to a service, except by the protocol, and that's it. But there are some differences, because you could use what is usually called subdomain routing. You could have a different domain. For example, in the same ingress resource, you could have bookflights.com, a different domain, and that will be redirected to a different backend service, which is Flights, a different service. And everything is defined in the same ingress resource. So you were able to centralize the definition of your forwarding or routing rules in a single resource, totally different to services. So that's great, but Ingress is one of those resources that the Kubernetes API will fulfill, but not entirely. For the ingress to actually work, you need an ingress resource definition, but you will need an ingress controller, which is basically most of the times a pod running in your cluster that will capture the configuration, that will watch the configuration in your ingress resource, and it will translate it into reality, right? It will become the data plane in some sorts. The ingress resource will be your control plane, and the ingress controller will be the data plane, who will, in the end of the day, will forward or route the request to different services. You can use different ingress controllers. This is not maintained by Kubernetes. You can use Nginx, very popular, the one that ships with the Flyte single binary. By default, it's Nginx, but you could use some others. I've met users who even have service mesh, which is even a layer above, or with a wide coverage, much more than ingresses. But here we are just discussing ingress. So you will need an ingress controller. This is why you will need them to be able to fulfill or apply in reality what is defined in the ingress resource, right? So yeah, that's it. I think it's time for me. Awesome. I just saw the chat. What I plan to do is to extend this into more detail in a blog post, also covering some recommendations on how to do it in different clouds. I see that there are some community members that could collaborate and bring their experience. I'm totally open to write this blog post with you all. It will be great, and probably will help some other community members to find guidance on how to make decisions and how to set up and get up to speed with Ingress. All right, any question or comment? Awesome, that's great. I haven't read everything that's in the chat, so all right, awesome. Okay, any question? Oh, cool. We will just end up with links and resources. Heads up that office hours move to an on-demand format. So if you want or need live support from Flyte maintainers, feel free to schedule a session using Calendly. The slots are the usual ones on Wednesdays, but it's now moved to an on-demand format. So feel free to schedule a session with them. All right, and for the next one, in 2 weeks, we will have some talks from Swift Technologies and some other updates for sure. So with that, thank you so much for joining this session and hope to see you in the next one. Bye-bye.
All right. Thanks, everyone.
Thanks. Bye.
Have a good rest of the day.